I thought I'd do a quick video of a circuit I pulled together from experimental methods in RF design. And it's this 30 watt amplifier, and in this case it's for 7 megahertz. And this comes from page 2-41 of the book Experimental Methods in RF Design. And I've always been intrigued by amplifiers, and this is no exception. Now, the circuit you can see here, and I'll just hold on this so if people wish to pull this together, they can they can take this circuit if they don't have the book. But it runs off 25 volts, and a 1 watt input is what's required here. There is an attenuator on the circuit here if you're feeding more than 1 watt. But I'm driving this with the kits and parts 5 watt, and I've got the output power turned down to 1 watt. So some of the other changes on this, the toroids you have to wind are all down here. Now, I wasn't able to find some of these. So in this case, this BN43201, that might be a typo. I haven't seen a 43201. And I replaced that with a BN43202. Similarly with this guy here, this is for T2, FT61114. I actually think that's another typo. It should be FT114-61. This is the diameter of the toroid in hundredths of an inch. And then finally, if you have a look at L2 here, 3 large ferrite beads, FB43801. I couldn't find any of these, but what I could find is FB43101. I had to actually use 7 of those to get 3.3 microhenries, and that goes on the that's an RFC on the input voltage right here. So what else? I didn't include this high-low power switch down here. Just for simplicity purposes, and I was running out of space on the PCB. What else? I didn't include this receive path here. I didn't really want to hook up my receiver to the amplifier until I'd kind of tested it. And you can see it's got some clamping diodes on here to clip the output voltage. I'd actually rather go with the proper receive transmit switch, and we'll come to that towards the end of the video. In the low pass filter here, instead of this 560 and 560 combination, I used a single 820 picofarad and 2 150 picofarad silver mica capacitors. These are all silver mica capacitors in use here. And then finally, on the receive and transmit, let me just pan down. What I wanted to do is there's a 12 volt signal that the 5 watt has on transmit, and I just basically put together this little BS170 based switch here, and that effectively turns on the bias circuitry right here. So I've replaced this part here with this FET base part here, and the purpose of this basically is just to turn the bias on transmit, and then there's no bias at all when there's no transmit, and it basically turns the FET off. So what else have we got going on here? The 5 watt output itself is at 7 megahertz, and I mentioned before I turned that down from the 5 watt output. What I'm actually seeing, and we'll see this on the oscilloscope when I start this up, is 112 volt, peak to peak output into the 50 ohm dummy load that I have here, and that's using approximately 1.3 volt bias. So the bias gets applied here to the grid of the FET, the gate. Sorry, not the grid of the FET, the gate of the FET, and that's at 1.3 volts. Interestingly, I've blown 3 IRF 540s so far in this, just playing around. So luckily they're kind of cheap. And so that 112 volt peak to peak output is actually 31.3 watts of output. And when we see on the PCB itself, I've got a tiny little heatsink which is way too small, so I'm just doing this quickly. So what we'll do now is we'll move over to the circuit itself, and we'll see it in action. Okay, we're over on the amplifier itself here. So here's the amplifier, and here's the 5-watt radio connected up to it. So just going through some of the circuitry. So here's this 12-volt signal coming from the 5-watt on transmit, and that gets to the gate of the FET, turning on the bias circuitry. Here's the BN43202 on the input. Here's the IRF 540 FET, and you can see there's a very anemic heatsink on there. This is L1, which is a 32 turns of number 18 on a T106-6. This is that FT114-61, and that's wound bifilar. So 18 bifilar turns on that toroid. Here's the low pass filter on the output that I spoke about, and then there's some matching circuitry here. Finally, this pot here is just used to adjust the bias to the gate of the RF 540. So let's pan up and see what we're doing up here. So I've actually got 27 volts coming into the circuit. I know it says 25 volts there, but I've got it up at 27 volts. And let's just pan over to the oscilloscope and get a good picture of what's going on key down. So let's just do key down here. So you can see there 112.8 volts at 7.0335 megahertz, and that's probing right at the output just before it goes into the dummy load. So what else here? That's about all I've got on this. I just wanted to pull together a little fun 30-watt amplifier. It's obviously not complete because you can only transmit through it. There's no transmit-receive circuitry. And on that note, I think I'll do a follow-up video. There is a QST article from way back in 1999, March and April of 1999, where there is a push-pull MOSFET HF amplifier that has full transmit-receive circuitry. So I think that's something I'll have a go at pulling together in a subsequent video. But anyway, that's all for now.